Now for the rule with horizontal asymptotes. I want to go back over to some things that we've done already, if I can find them actually. Do you remember back in classwork 5.6? I talked to you about why the situation of if the degree of the numerator polynomial is less than the degree of the denominator polynomial, your horizontal asymptote is on the x-axis. And did that make sense? So basically what you want to realize is, come back over here. If I have, say, x over x squared plus 1, a horizontal asymptote is looking at what happens when x is extraordinarily big. And if you remember way back in the polynomial lesson, when I went over, like, if you have x dollars, your friend has x squared dollars, and your other friend has x cubed dollars. And we looked at, with 10, the three of you can go shopping at the mall and not feel like you're in different, shall we say, social classes, because unfortunately that exists, but it is a bit of a reality of our world. When we got to, like, say you have $10,000 and you look at your x squared friend having, let's see, 10,000 means 3 zeros. Am I thinking correctly? No, 4 zeros. I'm a math teacher. I can count. Let me write the number so that I can see it. 10,000, 4 zeros. If x is 10,000, think about $10,000. It's a good amount of money, but what's it going to get you? Your friend x squared has 100 million. So you can buy a mediocre used car. They can buy pretty much any car they want, or a house, an amazing house, a couple of amazing houses. If you two were going to the mall to look at what you could buy, would you consider yourself in a very different class of what you're able to buy? Then let's hit x cubed. Yeah. Yeah. Let's see. Thousands, millions, billions, trillion. $1 trillion compared to 10,000, but even compared to 100 million. No comparison. That if x squared was a distant relative who died and gave the x cubed $100 million, would that x cubed even notice a difference in what they can do? They probably already own them. So what I want you to understand is when x gets big, polynomials of higher degree get so much bigger than polynomials that have a less degree that it affects that horizontal asymptote. What I just wrote here, the denominator is greater degree than the numerator. Because of that, the bottom is going to get so big in ratio to the top that this is literally going to head to 0. because that denominator is growing far faster than the numerator. And by far faster, I actually mean it's growing infinitely faster. So if the degree of the numerator is less than the degree of the denominator, you have a horizontal asymptote. And that horizontal asymptote is 0. The x-axis. Now, what if the degree in the numerator is greater than the degree in the denominator? And we did see a few graphs that did that. Let me grab Desmos just to show you. Let's see, let's make this a larger degree. Wow. I was trying to click that. There we go. So I'm going to make this x to the 4th power. Do you see a horizontal asymptote? Do you see a horizontal asymptote? Horizontal? Horizontal? Or do you actually see maybe an asymptote that is slanted and not horizontal? This does not have a horizontal asymptote, and we're not going to hit slant asymptotes in this class, but be aware that slant asymptotes exist. We're not doing that. All you need to know is if your numerator polynomial is a higher degree, then that numerator is heading to infinity and becoming such a bigger number relative to its denominator that that fraction overall is just heading to infinity. And I could then go, hey, how about I up that to x to the 5th? You see a horizontal asymptote? But do you see anything interesting? Do you see that the ends of this graph actually follow a quadratic? They look like it's a quadratic polynomial. I'm just going to throw that out there and then leave it alone from there. But that is what you need to know is if the degree in the numerator is greater than the degree in the denominator, you have no horizontal asymptote. And then we hit an issue that I forced you to do some tedious work on to get to a certain conclusion. If the numerator and denominator have equal degrees, I want to go back to when we did 5.7. With 5.7, I gave you rational functions that had the same degree polynomial for the numerator and denominator. When you went through the division, you were only able to get out of the quotient just a number, whenever that was your situation, because you have to take what you're dividing by, bring it down here. You've got x squared is the leader of what you're dividing by. The numerator is what needs to be added together inside the boxes. When you start off with that leading term of 3x squared, when you're dividing by a polynomial that leads with x squared, you get a quotient of 3, and any leftovers are a remainder. And that remainder gives you a polynomial where the numerator is less degree than the denominator, and the horizontal asymptote is 0. So I made you go through graphing the remainder piece over the denominator, see that horizontal asymptote of 0, and then the division let us know that we were adding 3 to the graph, moving it up 3 units. Horizontal asymptote is 3. When we graph that actual function, that is the original degree 2 over degree 2. Do you think, after looking at some of those examples, that you have an idea of how to find a horizontal asymptote without having to do division? X squared over x squared, we got 1. Oh, that's that same scenario again. So I'm going to throw another example your way. And no, there will not be a quiz today. Let's say I have 5x squared plus 2x plus 1 over 3x squared minus 6x plus 2. Let's begin a division on this without going through the whole thing. If I'm dividing by 3x squared minus 6x plus 2, and I'm trying to create inside the box the 5x squared plus 2x plus 1, the first thing I do is I write down the 5x squared in the upper right corner. And I ask you now, what do you multiply this by to get that? What do you multiply 3x squared by to get 5x squared? Anyone? Three x squared, I want to multiply by a number and have, yes. Now, that's the end of my quotient. Anything else is all about the remainder. So that means my lesser degree polynomial remainder will be moved up 5/3 units. And my horizontal asymptote is 5/3. Now, can you look at this original rational function? Oops, I erased part of it. Can you see how to determine that the horizontal asymptote is 5/3 without really doing much work? Do you see it? What you're going to always look at is, if it's the same degree, look at numerator polynomial and denominator polynomial. Look at the entire leading term. In other words, whatever x has that highest degree, look at it and its coefficient. That is what's going to lead the fraction as x gets bigger and bigger. That is going to lead this fraction toward a ratio of 5/3. So the rule is if the numerator and polynomial have equal degrees, the horizontal asymptote, first of all, it's not 0. 0 only happens in this situation. Horizontal asymptote is the ratio of the leading coefficients. And by the looks of all the people gathering their stuff and getting ready to go, I must be under a minute. So, I didn't record that, did I? Or did I? Did I record it?
I remember you starting it.
Oh, good. Yay, I did record it.